My fifth video in my module on quadratic functions, in which we are going to look at an application of parabolas, essentially. So we'll read the setup here in a minute, but in terms of applications of parabolic things or parabolas, one thing we're often considering are functions maybe like, you know, distance over time or temperature and percentage of people comfortable at a given temperature is actually the setup in this problem. But basically, the thing about parabolas is, of course, they look like U's, and so that being said, we're often using them in search of things that would necessarily yield a maximum point, which would be here, or a minimum point, which would be here. So we say mins and maxes, and our job is typically to go find a minimum value or a maximum value given some quadratically defined thing. Okay, so that being said, that's kind of a preamble to what it is that we're about to consider here, but what I want you to look at here with me is this. We say researchers say conducted an experiment to determine temperatures at which people feel comfortable. So here's the deal. We say the percent y of test subjects who felt comfortable at a temperature x, okay, so x is temperature in degrees Fahrenheit, can be modeled by this right here. So it's not so much how they got the model, it's just that we're being given a model, and we want to point a few things out about this. So we say y is representing the percent of subjects that were comfortable, okay, percent of subjects comfortable. This is important, comfortable. And then x is equal to the temperature, the temp, and we're talking about degrees Fahrenheit. Degrees Fahrenheit, okay? So this being said, what I want to do is this. We're not actually going to graph this, but we see that it is quadratic. We see that this is something that is quadratic and it is in standard form. We say ax squared plus bx plus c. Okay, this is our standard form of a quadratic. And the fact is, if we were to say necessarily sketch you know, a rough sketch of this, we'd say x down here, this represents temp, okay, and y up here we say is the percent comfortable. The thing about quadratic things is, you know, of course we know quite a bit about them at this point, especially the a value. The fact is the a value here is negative. So what this means is we have some quadratic curve that is opening downward. So in our minds we need to conceive of this as being something that necessarily looks like this, or just, you know, looks somewhat like this. But the fact is, you can see that as our temperatures vary, we say if I had a very low temperature right here, you know, this would yield a smaller percentage of people who are comfortable because it's cold. Or possibly we would say at a very high temperature right here, you know, we'd have this percentage of people comfortable on the y-axis. And so basically, you know, it's too hot, they're not very comfortable. What we're looking for is the ideal temperature. So really, when people ask you to use quadratic things, what they're really typically asking you for in application problems is to find the vertex, okay, because that would be the maximum of this. So we'd say the vertex in this case is some x and some y. What I want to point out is this. It is some x value, which represents temperature, and then the percent of people who are comfortable at that temperature. So there are two questions I really want to confront on this problem. They're going to be really easy to figure out because we know a lot about things in standard form already. But we say find the temperature at which the maximum number of people feel comfortable, and also find the percentage of test subjects that felt comfortable at that temperature that we found in part A. So what I'm really asking for here is, first of all, let's find the temperature right here, this temperature at which people are very, very comfortable. And then we're going to find the percentage of people who are comfortable at that temperature by plugging that x value into our function and going back and solving for y. So let's start with the maximum number of people who feel comfortable with this. For anything in standard form, recall, you know, we have y equals ax squared plus bx plus c. If we're looking for the vertex, recall that the vertex is at negative b over 2 times our a value, and then the y value would be what we get when we plug that into our function. But right now we want to find the temperature, so we're going to find this negative b over 2a thing. So we'd say, well, the x value, or the temperature at which most people felt comfortable, or at least the temperature at the vertex, would be at negative b over 2 times a, which is negative b in this case, and 2 times a. We're going to leave ourselves some room because our b value here, you see, is 527. I didn't leave myself that much room. 527.3, and then our a value is negative 3.675. 8 is the number that I've given us here. Okay, so we need to find this. First of all, we get a negative over a negative yields a positive. And the second thing I'm going to do here is I'm going to get the calculator out, 527.3, but we'll actually, let's open up our calculator. And there she is. I'll drag this over here. So 2 times negative 3.678, let's just do the numbers here. We already know that this comes out to be positive because of the negative over negative, but 2 times 3.678, we get 7.356. So 7.356. So pulling the calculator back out now, we'd say 527.3 divided by 7.356, and we end up with 71.7-ish. Okay, so we'd say this is approximately 71.7. Now I want to recognize at the beginning here we defined our variables as x being temperature in degrees Fahrenheit. So this is degrees Fahrenheit is what we've just found. We want to label this. People often lament on these problems about the numbers. And it's like, you know, it's not the numbers that you need to be good with. You have a calculator to do the numbers for you. It's the process that you're going through. So all we need to do is find the vertex and interpret our results. And our results say that basically, if we were to look at this graph, if we were to graph it, 71.7 would be the x value of our vertex right here. We say 71.7 is the x value. In other words, at 71.7 degrees Fahrenheit, the maximum number of people felt comfortable. Now we want to know, so what percentage of the people was that? So that's like saying, well, hey, if I know the x value of my vertex now, we know the x value is 71.7, how would I find the y value? Well, we'd go plug that in. That's as easy as that. We go plug it into the function and find out what we get for a y value. So we'd say f of, or the y value when x is 71.7 would be this. We'd say negative 3.678 times blank squared plus 527.3 times this to the first, minus 18807. So here's our function. We actually do have to plug in a 71.7 in each of these instances. And so we're going to have to do this in pieces, yes, because I don't have a graphing calculator in front of me. But essentially, we're going to start with the order of operations, start with our exponent. So 71.7 squared, good news, I have my calculator right here. So we say, okay, so 71.7 power of 2. We get this here. Now, that result we're going to take times this negative 3.678. So times 3.678 negative equals negative 18908. So we get approximately negative 18908. And yeah, you know, I actually want to keep a couple decimals on this, 0.19. So 0.19. So now we're going to evaluate this middle portion here, 527.3 times 71.7. Not a bad thing to do. We say, okay, so 527.3 times 71.7. We get this value, 37,807.41. So 37,807. I believe we said 0.41. Yes, we did. 0.41. And all of this minus 18807. Okay, so now we'll just bring the calculator down underneath all this and we'll type in this entire expression. So we had 18908.19, this was all negative, plus 37,807.41, enter, minus 18807. So what we yield is this 92.22. So we'd say this is approximately 92.22. Now I want to interpret this because this is our y value of our vertex. We say the vertex then is at V is 71.7 degrees, and we say 92.22. In the first instance we said the y value was the percentage of people who are comfortable at a given x value. Well, this means up here then the percentage of people comfortable at this given temperature is 92.22%. So what we can say is this: just by finding the vertex, we were able to find the temperature at which most people felt comfortable and the percentage of people who felt comfortable at that temperature. So not a bad thing. It's kind of like if I had given you this equation to begin with and said, go find the vertex. That's essentially what we did, but we needed to interpret our results. Cheers.